to my channel. So here is the question of Newton-Raphson method, that is log x minus cos x is equal to 0. Correct up to 3 decimal place. So for this solution, f of x is equal to log x minus cos x. As you know, the formula of Newton-Raphson method is, that is xn plus 1 is equal to xn minus f of xn by f dash of xn. F dash means derivative. Okay, so formula, that is x1 is equal to x0 minus f of x0 by f dash of x0. Okay, we will use this formula. So now here we have f of f dash. Okay, so we can find, so f dash of x, so the derivative of log x is 1 by x, and the derivative of cos x is minus sin x, so minus minus becomes plus. So it is the derivative of f of x. Now we have to find out the interval up to which the root lies. That means finding root interval of f of x using tabulation method. As in the question, we have trigonometric terms, that is log x, cos x, we have trigonometric terms. Okay, so we have to change the calculator into radian form. So press shift, then press mode, then after this press 4, that is radian mode. Okay, now to find out the interval, so for this press mode, then press on 7, then give this function. Okay, so here we have log x. So always remember that if we have, suppose log base of 10 x, then in calculator always write log. Okay, log of x. If we have log base of e or only log, then we have to write the ln in calculator. Okay, so that means here we have only log x, so that means we have to write ln, then alpha, then x, then minus and cos and x. Now after this press is equal to, now we have to start from 0. Okay, so start from 0. Now in means up to 5 term, so and step means 1, press 1. Now here you can see in the, so I can write this as x f of x. So here we have 0 1 2, error means infinite. Okay, and in the, if x is equal to 1, we obtain minus 0.5403, and in the, if x is equal to 2, then we obtain in the function 1.1092. As in the question, we have been asked up to 3 decimal place. Okay, so we have written up to this 4 point. Okay, so the root interval lies between 1, 2. Okay, so as here is the sign change. Suppose if we have here minus sign, again in the point, if x is equal to 3, if we have 2, then we would have written 2, 3. Okay, but here we have the sign change in this 1, 2. So we have written this interval. So sign of f of x changes between interval 1, 2. So at least one root must lie between corresponding interval. Okay, now as here you can see, we have only x0. Okay, we only need x0 term, so that means, but here we have 2 interval term. Okay, so we can take, so let, as we have to take only 1 interval term, so we can take the median of this term. Okay, so 1 plus 2, that is, let x0 is equal to 1 plus 2 by 2, then we obtain 1.5. Okay, so we take x0 is equal to 1.5 be initial value of root. Now after this, so here we have, as we are here in the formula, we have f of x0, so we have to find f of x0, and f of x0 means f of 1.5. Okay, f of x0 means f of 1.5. so if we press here is equal to 0, 5 interval 1.5. so here you can see, if x is equal to 1.5, we can obtain, we have obtained this 0.347. As we only need up to the 4 terms, so we can change this, clear, then shift mode and press 6, that is 6th term, so press 4. Okay, so that means if we put 2 into 5, then here you can get, see, we can obtain only up to 4 term. Okay, so now after this we have to find the f of dash, that is derivative term. So f dash of x is equal to f dash of 1.5 is equal to, that means 1 by 1.5 plus sine 1.5 That means we have obtained 0.6928. 0.6928. Okay, we have obtained up to this term. Now we have to apply the formula. Now applying formula of Newton-Raphson method, that is, we can write this as NR method. Okay, so we have the formula, that is x1 is equal to, so here is x0. Okay, so x1 is equal to x0 minus f of x0 by f dash of x0. So here we have x0 means 1.5. 1.5 minus f of x0 means 0.3347 and 0.6928. So we have 0.3347 by 0.6928. So we have obtained this. So 1.5 minus answer. So we have obtained 1.0169. Okay, the value of x1 we have obtained this. Okay, f of x1. Same. F of x1 means ln answer. Answer minus cos answer. Okay, that means we have obtained minus 0.9831. For this, we have to make the iteration table until we get the iterative solution or iterative value that have 3 decimal place per point. For this, we have number of iteration. Then, as in the formula we have here, so x0, f of x0, f dash of x1, and sorry, x0 and x1 and f of x1. So we'll make the column likewise. So x0, then f of x0, then f of x0, that is f dash of x0. Okay, then x1, then f of x1. Okay, and in the Newton-Raphson method we have x0 is equal to x1. Okay, so obtain this from algorithm of Newton-Raphson method. Okay, so always remember x0 is equal to x1. So we have to find out the value. So here in the iteration 0. Okay, in the iteration 0, and here we have the value of x0 is 1.5. Okay, so place the value of x0 is 1.5. Now we can find out the rest of the value using calculator. Okay, so for this we have the simple trick or formula type method. So here you can see, suppose this x0 is a. Okay, and this f of x0 is b, this is c, and this is x. Okay, capital X, and this is y. Now after this in the calculator, so for the calculator we have the formula like, so that is, so we can write this, we can write in this variable in the calculator in the form of formula. That is, suppose here you can see it is a, here is b, so x0 means a. So if we have to next variable we have to give colon. Okay, now here in the b, now here you can see it is f of x0. Okay, so f of x0 means we have function. Okay, function placed in x0. So yes, we have suppose x0 is equal to a, so we have to write this function in the form of a, that is equal to, so is equal to ln a minus cos a. Again we have to write this c, so colon c, and here you can see it is the derivative of function. So and here is also x0. Okay, so again we have to write this derivative function in the form of a. So that means c is equal to 1 by a plus sine of a. Again here we have to give, write another variable, so we have to give colon and x. As you know here is the formula x1. So x0 minus f of, as we have suppose x0 is a and f of x0 b and f dash x0 c. So it becomes a minus b by c. Okay, so we can write this as x is equal to a minus b by c. Again here colon, after this give colon, and y is equal to, as we have suppose f of x1 is y, and here you can see it is f of x1. That is, we have to write this function in the form of x, capital X. Okay, so that means ln x minus cos x. Okay, now we have to write this all the term in the calculator. Okay, and we can find out the value easily. So for this, so here is the term. Now after this, so for this here you can see, so always remember that we have to change this calculator into radian form. Okay, yes, here we have the trigonometric term. So this calculator is in the is not in the radian form, so we have to give this in the radian form, shift more and 4 radian form. Okay, now after this press, we have to write this, so alpha a, this is variable, then for colon press this, and again b is equal to, then ln a minus cos a, again colon, then press this press c. Okay, c, then for is equal to press this button. Okay, don't press below button, press else, then 1 by a plus sine a, again colon, then again x is equal to then a minus b by c, okay, b by c, again colon, again y again is equal to ln, and here is x term, okay, x minus and cos, and here is x. Now after this, don't press this is equal to, okay, after writing all this variable, now press this cals, okay, cals. Now here in the a form, so we have to give the value, okay, so as you know, we have suppose a is x naught, okay, so in the x naught we have the value 1.5, so give value 1.5, so and leave all the value as it is, okay, so for all the other term press is equal to, leave this as it is, okay, is equal to, and after this here we have obtained this. Now in the b we have obtained this value, okay, so in the b write this value 0.3347, then in the c we have 1.664, in the x, this capital X, okay, 1.2989, and in the y we have obtained minus 0.0071, and as I have already written here, x naught is equal to x1, so shift this x1 value to this x1, okay, for the next iteration. So after first iteration, so shift this value here, okay, so that means write this value in here 1.2989. now after this, after writing all the value, press is equal to, now we have been asked to enter the value of a, okay, that is x naught, so now press, so 1.2989, you can either enter 1.2989 or as here you can see we have here a and here is x, that means a is equal to x, that means the value of x is transferred to x, sorry, a, okay, so either you can enter the value or you can press alpha, then press here is x, okay, so you can enter x, okay. So now after this press is equal to, now leave all the variable as it is, okay, so don't enter any value. Now press this, now so here is one value of this a, and here you can see it is the value of b, so that means x naught is equal to x1, that means here you can see 0.0071, and here you can see x1, this value is transferred here, okay, so I have calculated this from calculator, so here you can write minus 0.0071, and for this c you have 1.7332, and for the x 1.3030, and for the y 0.000, okay, so we have to obtain the value of this, again shift this value in here, okay, so press, so for this 1.3030, now after this, so here is press is equal to, now as it is alpha x, okay, is the value of this x is transferred to a, so alpha x, and now press is equal to, leave this all as it is, and so here you can see we have obtained the value of 0.00, so b value is 0.8 there, and the value of a is 1.7318, and the value of 1.3030, and the value of y 0. And as here in the question we have been asked up to 3 decimal place, okay, so 3 decimal place, and here in the question x1, that is x, here you can see we have the term that matches up to 3 term or up to 4 term, 3.03, 3.03. so at first and second iteration values matches up to 3 decimal places, so root of function is, so write this value, okay, 1.303, at here we have obtained the function value f of x is 0, so in this way we can obtain the solution.